So today we're going to be talking about center of mass. And so I've got a wood structure here, and I'm going to add this 5-pound weight. And pretty much our question is, when we add this, is it going to tip over or is it going to not? And so let's dive farther and take a look at it. So here's the definition that we're going to use for center of mass. And we're really looking for that point that things are balanced on, right? Like mathematically, we're talking about where all our moments sort of cancel out and that the sum of all our forces equals 0 at that point. But really, if you think about it as a balancing point, it's easier to conceptualize. So if I want to apply this, let's say I'm building a structure that looks like this, where I have a vertical point and then I have to cantilever over a support or a mass right there. If I break it down into a free body diagram or try to simplify it, I'm going to have this structure right here. I'm going to have a vertical structure here, and I'm going to have a mass over there. What I'm then going to do is I'm going to find something that's called the centroid of it, which is the center of that mass. These are kind of nice in the fact that they're squares. And so if this has a height of 1, I know that the centroid is 0.5 high. And then if I have a width of 8, I know that it's 4 over. Same thing here, except I want 8. And with this being 2 wide, I want back 1, so I know it's 7. This one being 8, this is 2 wide also. I know that it's 9 because I'm adding that 1 more inch. And so what's going on is we're taking the sum of all of our masses times our distances and then dividing it by our masses. So pretty much we're getting the average of the distances in relationship to the number of units of mass. And so in other words, this would be like two units of 9 inches. This would be 4 units of 7 and 1 unit of 4. And that's just the way that sort of works in my head as far as how it goes. And so I've got those moments sort of set up, and then I'm dividing it by a total mass to get my x value, which is the center of mass in the x direction from that point. So that breaks down to this calculation right here. So again, we got 1 pound times 4, 4 pounds times 7, right? And then we get 2 pounds times 9, and we're dividing it by the 7 pounds of our total structure there. I get that down, and it ends up being 7.14. And we can then map that out. So this is 8 inches wide, and we know 7.14 is going to be coming short of that. And so I can mark that location for my center of mass. It would be right above this. And so the question is, will that part fall? All right. And so I would probably, like mathematically, it's going to say no, like it's not going to fall. But they'd probably be like, it might be a little bit wobbly, right? Like if you get it bumped just gently from this side, it might fall. But that's the basics of the math on it. So let's look at another example. Our base here, we're going to measure from this point right there. So it's going to be 13.5 in length, right? We're going to have a 4x4, which is 3.5 wide. We've set it up 9.75 to its centroid right here. Our beam up here at the top is 2 foot wide. We've put it directly above the centroid for our 3/4 inch tube. And then we're adding this weight right here. And it should hold for us. All right, let's look at the math for this problem real quick. So I built an Excel table to work with here. And what we've got is I've got all of my components. So I've got my base, I've got the mast, my sliding arm, which is this one right here, and the 5-pound weight. And I've got it calculated from this location to sort of modify this graphic and be able to sort of update as we go. And so 9.75 is what we have. And so it provides me the x direction of the centroid of each of those items. We've got our masses in there, and then we find our moments. If I go in here, I can see that I'm just calculating between the two of those. And then here I'm summing up that, and here I'm summing up my total mass. And then what I'm doing is I'm taking D6, and I'm dividing it by, C6. And that's giving me my centroid, which is 12.25 to there. So it's going to be right on the edge, but in this situation, it should be stable. So let's put it back up on there. Click. And we're good to go. Right? And, you know, I could push it down, have it tip, but in that situation, it is going to be stable. So let's look at our other situation that we talked about initially. So I'm going to loosen this up. I'm going to rotate my board and take it all the way out there. All right? And let's look at the math real quick again. So none of my components are changing. I just need my x values to modify. And so I'm moving this back a little bit to 7.75. and my offset is going to put me 6 in the other direction. And so we can see that my new value is 13.42, and my entire board here is 13.5. And so, of course, it stands. Barely, that stands.